Okay, now let me record. So I'm recording. So this is section 1.5 I'm going to start with. So basically here, we saw equations already, right? We saw what an equation is, what it means to be a solution of an equation, that kind of thing. Here, what we're going to do is we're going to kick it up a notch, so to say. Namely, we're going to deal with inequalities here. But before we deal with inequalities, we have to see what the interval on the real number line is. We have to see what an interval on the number line is. You'll actually see that with inequalities, just like equations, they can have solutions. Their solutions are not going to be just one or two numbers. It's actually going to be an interval, as we'll see when we do some examples. Probably not today, though. We're also going to see what an inequality even is. You'll see it's actually, It's actually very similar to an equation. I mean, basically, it's what you get when you have an equation and you replace the equal sign with an inequality symbol. Okay. And the book does go into this. I've had this on exams before as well. We're also going to see how to graph an inequality. It's not that bad. We're not actually up to the Cartesian plane yet. That's going to be in chapter 2, which is actually after 1.6, the next section. So anyway, this is what I want to cover in 1.5. So first, I just want to briefly review the real number line. It's just a visualization of the collection of all real numbers. It's kind of like that saying, a picture is worth 1,000 words. So it's just a way of visualizing it, the real number line. It's a way of visualizing the collection that is, of all real numbers. The idea is on the line somewhere, like over here I picked, you set that to be 0. 1 unit to the right is 1. Another unit to the right is 2. And so on and so forth. You keep on going. Even though I stopped at 4, you could keep on going indefinitely. On the left side, it's the same idea, 1 unit to the left, except now it's -1. Another unit to the left, we get -2. And you keep on going to the left. You keep on doing that. And every real number corresponds uniquely to a unique point on the line. So like halfway between 0 and 1, you would have a half. A quarter of the way between 0 and 1, you would have a fourth. Same thing on the other side, except those numbers are negative. So now the real number line might be very basic for you. If it's not, that's okay. But that's where intervals can be drawn. In other words, well, before we get to that, let me just define what inequalities are, which involves the real number line. If you have two different numbers, A and B, right, where you have this, A is on the left side of B on the number line, we say A is less than B if A is on the left side of the number line. So in other words, if we have two different numbers, A and B, right, basically we say A is less than B if it's to the left of B on the number line. The idea is the further to the left you are on the number line, the smaller you are. And notationally, we write this. I know this looks like the tip of an arrow. Okay, but this is what it means for A to be. This is how we denote A is less than B. And we can also say B is greater than A, as you can see. If, again, A is less than B. So notice the order in which these are written. That actually does matter. A is on the left side of B. Okay? So again, the further to the left you are on the number line, the smaller you are. So if we went back, 0 would be less than 1. 0 is on the left of 1. -2 is smaller than -1. -2 is also smaller than -2, and so on. And then let me just let me quickly say this. Here, we did not allow A to be equal to B, right? We said they're different numbers. They can't equal each other. But if we allow equality, then we have this. So if you have two different numbers, A and B, we say that A is less than or equal to B if A is less than B or A is equal to B. So it's really what it sounds like. We also say B is greater than or equal to A if B is if A is less than or equal to B. So basically here we're allowing equality. So it does make sense to say 0 is less than or equal to 2. I wrote here 1 is less than 2 just from the previous slide. But you can say, for instance, I didn't write it, that 0 is less than or equal to 0. Okay, it looks like we're out of time, so I'm going to stop here.